Cool. So awesome to be here in Poland. It's my fourth EDA day that I've been part of, so it's absolutely great to be here. And today I'm going to be talking about this, which is complexity. Okay, complexity with event-driven architecture. And complexity is this thing that will come and get you no matter what you do. Okay, you've got the accidental complexity, especially as you're building distributed event-driven systems. The last kind of 8 years, I've been diving deep actually into EDA. I actually built event-driven systems, found this potential, this agility that I'd never seen before in 16 years building software architectures and systems. In fact, I just dived deeper. I worked at AWS to continue to just evangelize it, okay? And event-driven architectures have this potential, right? And all you've got to do is Google event-driven architecture, you start seeing some words come up. These words are like, fault-tolerant and decoupled architectures. So we start to see, the pretty picture up there. And it's true, there are many benefits of event-driven architectures. This is kind of why I love it so much. But the thing is, with event-driven architectures is that you inherit this sea of complexity, okay? And when you can see this iceberg and that potential, the things we talk about, all the blog posts you read will talk about the stuff at the top, but there's so much more to get with event-driven systems, okay? And what we can do is actually manage this complexity. If we put guardrails in place, understand that it exists and how do we manage it, we can actually then find and actually understand some of that full potential. So in this talk, I promise you to walk away with 3 different guardrails you can put in place, and also understanding this potential itself. And I actually honestly believe, after years and years diving into this, is if you don't manage this complexity, and at the start it won't be there, but after a few years, I can guarantee it will be there, that you just won't unlock this potential, okay? So what are we going to be talking about today is this. Number 1, diving into that potential of event-driven architectures. Number 2, we're going to be looking at 3 takeaways you can take away today in action in your organizations, in your companies, and your businesses. If you're building event-driven systems, if you're thinking about it, there are 3 things to take away. And finally, I'm going to be looking at the one gotcha that will get you when you build event-driven architectures. Every person, every enterprise, every customer I spoke to fall into this trap. And I'm going to explain what that is, and I'm going to explain how you can avoid it. Before I do all of that, introduce myself. My name is Dave Boyne. As Eric mentioned, I previously was a developer advocate at AWS for a few years. I actually recently left 3 months ago to actually focus more on tooling and open source work. So I have 2 jobs. Number 1 is I do tooling around event-driven architectures for free. So we'll be speaking about some of that. And number 2, actually, I'm a developer advocate at Wing, which is a programming language we're building for the cloud. Okay, so this talk, we won't cover that. But if you're interested in any of them or seeing some demos or some stuff, feel free to grab me after that. That'd be great. And equally, I wrote something called EDA Visuals, which I'll share a link at the end. But let's talk about this potential, okay, of event-driven architectures. I remember in 2022, who's been to reInvent before? Has anyone here been to AWS reInvent? Okay, a couple of hands. So in 2022 was my first reInvent, my first year as an AWS employee, and absolute carnage. 60,000 people walking around Las Vegas. It's a sight to be seen. And but I remember this year, Werner Vogels, he's the CTO of Amazon, had a whole pitch on event-driven architectures in his talk. It's a great talk, actually. I actually recommend watching this. And he said one thing, one sentence in this talk that kind of stuck with me. Right? And he says, the systems that don't evolve will die. Okay? That really got me thinking about event-driven architectures, evolutionary architectures, and equally the idea of static architectures. Kind of got me thinking about architectures that I've worked in the past, I've been part of, building both. And I see people building these things over and over again. On the left here, we have static architectures, the things that hold us back, the things that kind of make it slow and frustrate us as we're building systems. Now, don't get me wrong, we don't go out and build these architectures with this in mind. but sometimes it kind of creeps up on us. Here on the right, this push for evolutionary architectures, decoupled architectures, being able to add functionality over time. So let's have a look at the differences here. Now I'm going to tell you something here that's going to blow your minds. The most scientific thing you have heard all day. Right? That is, knowledge increases over time. Thank you. Thank you. Look at that. Even get a clap. No, but this is the thing, okay? Knowledge increases over time. We know that. So, why is it when we build systems and architectures and all this kind of stuff, is we have these decisions, we make these decisions up front. Okay, so we go build something, we have these decisions, but we only really get that knowledge of our domains, our models, our schemas, our events, our messages, what we're trying to build later on. This actually is interesting. It actually has a word. This word is called project paradox. Okay, so we start off and we build this thing without necessarily knowing the knowledge that we need to know. For me, this is the risk. Here is the risk of static architectures, building systems that may kind of slow us down. Static architectures tend to have these different things here. Number one, being tightly coupled. Okay, your architecture, hard to make changes as time goes on. Yeah? We also have this low cohesion, decreased quality code. Maybe your code or your functions, your services, whatever they are, your containers, maybe they're doing too much, and that's grown over time. The interesting thing here is that it leads to the lack of experimentation in your organization. It becomes hard to experiment. It becomes hard to integrate with that new AI, LLM models, or whatever it is you want to do, because the systems are so kind of coupled and static, I guess, in a way. And finally here, it's about team interdependencies. So we try to make change in our architecture. When we talk to team A and team B, let's talk to Tina, we need to make a change to this particular contract. Okay, to do that, I need to talk to John. John's over here in this team. That's fantastic. It's only a schema change, but why is it taking us 3 weeks or 4 weeks to do that? Because everyone's got different priorities, different things going on all the time. So it becomes a very interesting thing because you start to have this frustration that happens in the organization with your architectures. And I've been there in the past. I've worked on teams, and it is very frustrating. Everyone's there to do the same thing. We're there to serve the business, I guess, at the end of the day. But why is it that tech is not the enabler that we want it to be? Why is it taking so long to implement something? Okay? This is kind of that nuances, and this is the thing, that feeling that I get when I see, and I continue to see today, people building architectures in that particular style. So if we take a step back for a minute, there's this report out earlier this year, this Gartner report that I read. It says about 60% of organizations are focused this year on speed and agility. Okay, it's an interesting time, actually, the IT market at the moment. We have various different things happening all over the place. But that speed and agility is an interesting one, especially as we look at things like Cursor. Has anyone used Cursor, the new text editor? A few people. Right, you can instantly create applications through commands and all sorts of things, Copilot, Amazon Q, whatever. You take your pick. But the interesting thing I think is going to happen here is the business is going to expect some kind of agility as we see these tools making us faster and faster. So if we go back here and think about speed and agility, well, how can we do that when we're at risk of the static architectures here? And I believe, to be honest, what we need to do here is actually try to defer our decisions later on. Okay, and we can do this with event architectures, with our messages, with our events that we raise. We can build an evolutionary system, an evolutionary architecture. And one of the principles of evolutionary architecture actually is to enable incremental change. So now if we look at the characteristics here versus what we had, we see the words loosely coupled coming up, okay? Easier to make changes. High cohesion. Maybe we have services or small things doing one thing and one thing very well. This is possible. And equally here we have a platform to experiment. Okay, this is pretty cool stuff. So an example here is we have an event. One thing I like to promote is actually raising events when you have no consumers. Your events, some of these events are going to be domain events, business events, that an order has been placed as an example, or someone's just checked out something, or whatever it is. We can raise these events, we can evolve as time goes on. We can have downstream consumers in a month's time, 6 months, or a year, consume these events, and have this evolutionary approach to our organization. And then finally here, team dependency. If you can find the events, discover the events, understand the schemas and the context of the events and the messages, why can't I just consume it? Okay? And EventBridge is an example of that. As I use AWS services, or any broker, in fact, we can raise these events and consume them. So I actually believe that evolutionary architectures can lead to innovation. Okay? And when you lower that cost of integration between systems, you can create explosions of innovation. So when we compare the two, the static versus event-driven versus evolutionary architectures, there's this thing where it's kind of like, okay, well, static architectures can lead us to frustrations, and on the other side here, we have event-driven architectures could be an enabler. Now, there's one problem with evolutionary architectures and event-driven architectures in general. Is in fact, they lead to complexity. Actually quite difficult. Let's have a look at a basic example. Okay? So we have an order service here, we have a channel in the middle, a broker, EventBridge, SQS, or RabbitMQ, or Kafka, doesn't really matter. We have consumers here on the right consuming that message, kind of a pub-sub pattern here. We as the order team today have been tasked to raise an order-placed event. Fantastic. Well, we've just read online on Serverless land or whatever else how to do this. In fact, we can use EventBridge, a managed service, as an example. That barrier to entry is lowering every day, every year. So we say, yes, we can do this. Let's go and do this as a team. So what we start to do is we start with an event. Okay? So we look at the documentation, we say, yes, fantastic. We have a detail type. The order has been placed. I think that's a good naming convention. Okay? We have a source. In EventBridge, this is a way, I guess, to map like groups of events. I tend to use it as domains. So the order's domain has raised this event or the service. Fantastic. We're on a roll. Down here is the schema, is the payload. This is up to us as a team to define. So simply, what can we do? We can add the order ID and the user ID in here. No harm done, right? So we move on. So we raise an event, and we have consumers. In fact, this managed service has done all of this for us. Fantastic. We just need to raise events onto it. So 3 months, 3 weeks, whatever it is, comes down, and we got another event to raise. This team over here, the business, want to know when an order has been cancelled. We want to send some emails as an example. Well, we've done this before. We can do it again. So we go back, we copy and paste some code. We have a schema, an envelope, a message that we can raise. So now we have the order cancelled event, and we have some new properties. Property number 1 is the reason. It is no longer needed. Now this might be useful. So the email system, you cancelled the order because you said it was no longer needed. Here, we have type TW. When you cancel an order, okay, the type TW here. Does anyone know what TW means when you cancel an order? No one in the room. I don't know what it means. I made the slide, okay? But what's happening here is implementation details of this service have started to leak. Okay, it looks harmless, but there's consequences. And down here we have a user object. We have the ID, the first name, the last name. But remember that other event that we had, we just had the user ID. So why have we got an object now? Is this PII information? Should consumers even have first name or last name? Don't know, don't care. So we carry on. We're flying. Okay, we've got events now. We have a new event, order updated event. We can just keep going. In fact, we go to the whiteboard and we start drawing boxes and lines because it's like we like to do this as architects, as engineers, to our CTO to justify our jobs. It's fantastic. And in fact, other teams start to look at us and think, some cool stuff going on here. I want some of this. I'm going to be a consumer of your event. And we keep building up on the system more channels. But we're using SQS, EventBridge, we're using RabbitMQ, we're using Kinesis and Dynamo Streams, all sorts of things. In fact, more teams come on board and say, yes, this is fantastic, absolutely. Look at this decoupled, beautiful architecture with lines and boxes and channels and event-driven. I've just come back from Poland and look what I've built. But 9 times out of 10, what we have built is just a big ball of distributed mud. Okay? And complexity, coming back to complexity, lies within the lines, within the details, within the way we consume messages and publish messages. And talking about complexity here, let's have a visual representation of complexity and how fast it can grow. So here we have 3 nodes. 1, 2, 3. This could be 3 of us talking after this. This could be 3 of us in the pub. This could be 3 messages, 3 brokers, 3 systems. Doesn't really matter. The 3 possible channels in this diagram. So what we do is we add 2 more nodes here. So we got 5. So now we have 10 channels of communication. Okay? So what happens if we add 2 more? We go to 7. Now we have 21 different channels, ways, possibilities of communicating with each other. Again, 7 people in a pub. These are the conversations of flying. So what we do with event-driven architectures is we start to lean into channels and brokers to manage this for us. We start to use EventBridge as an example, AWS solution, say, okay, I'm going to implement some managed policies. You can't talk to whoever you want. I'm going to introduce some of this stuff. Which sounds fantastic on paper. We start to draw this up again. A, B, and C, channels. Now this looks simple. But again, that complexity comes in the details. Number 1, unclear domains. What is A? What is B? What are our domains? What are our contexts of these domains? Number 2 here is schema definition. Okay, how do we define our schemas? How do we evolve our schemas? How do we change our schemas? Backwards compatibility, all these issues that will arise. It's just a matter of time. Here, one of my favorite ones is how we consume messages. Right? It can couple you directly back to the producer. So what can we take from domain-driven design and help us here? And then another one here is language. Language that's used between domains, between our messages, between our models. You know, a policy over here on the order system can be completely different to a policy over here on a payment system. Okay? And you often find these things. So how do we deal with all of this? What rules and what things can we put in place? And I believe there are guardrails. Here are 3 guardrails you can put in place. Number 1 is understanding implementation versus behavior and what we can do here. Number 2 is about event evolutionary strategies. How do we evolve our events? What options do we have? And number 3 here is about defining some kind of mappings between consumption of events. So the first one here is about understanding behavior versus implementation. So you may be kind of energized after Poland, EDA day, and go away and start experimenting with some of this stuff you've seen today. Start implementing. As I said earlier, that barrier to entry is lowering every year. There's new SaaS providers, PaaS providers coming out in the event-driven space at the moment, meaning you can literally pump messages to queues that you don't control. and B, start becoming event-driven. So there's this implementation phase that we're excited about and we want to do. And what tends to happen, you fall into this weird and wonderful trap. You start to implement, right? We have value over time. And when we implement, we start to have our initial producers and consumers. There's this bump in value that you get. You start feeling great because we raised an event. We've got a consumer and things are working for us. Okay? We have more producers, more consumers over time, and that's fine. But you start to realize after a while, and this could be a year or months, whatever it is that value that you initially got tends to plateau. Now, why is that? Well, let's map complexity onto the same graph. So here, what tends to happen with event-driven architectures is that complexity seems to come. It's this thing that's hidden, seems to kind of come out of the darkness, and it's just all of a sudden there. So here we have the initial producers and consumers, and then assumptions start to get made. Assumptions about the domain, the models, the schema evolution strategies, the consumption strategies, whatever it is. How do we know who's producing what, who's consuming what? That's a big problem. It's an interesting one, really, if we talk about understanding, okay, and that implementation first mindset. And this is a great quote from the author of Event Storming, but he says, it's often the misunderstanding that gets released into production. Okay, now if we applied that to event-driven architectures and that implementation first, you see this all the time. So what happens if we actually take a step back and understand behavior first with event-driven systems? What can we get? When we talk about behavior first, we talk about understanding the behavior of the system that we're trying to model. We identify events. As we identify events, we work with and collaborate with domain experts, right? Events can be business events. Events can be technical events, whatever it is. But we need to map and visualize this somehow. It can really help you understand what it is you're building, especially as you kick off or even explore your event-driven systems. And then finally here is talking about language that's used in the organization. I can't tell you the amount of meetings that I've been in doing this mental model just between the same model, literally models and language in these meetings. Examples being, we're talking about policy, but you call it something else. But we're talking about the same thing. And with event architectures, we can actually embrace that. And one way we can do that is actually using something called event storming. Has anyone done this before? Cool. So a few people, about a quarter of the room. So two things you can do. Event modeling and event storming can really help you. So workshops you can use and you can run with your organization. Workshops you can get your domain experts into a room and start mapping out your system, understanding your system, using commands, using reads and using events as an example and mapping them into domains. It's a fantastic and interesting workshop to run. And most of the times, it's actually, the part I like the most is actually the arguments that we have between each other, understanding the nuances between the naming conventions. Here's an example I like to share when I do these talks. But this is a basic example of a car park system. So we build a car park system, I come in, I grab a ticket from the machine, and I park my car. Now, it also allows me to extend it on the mobile phone. Right, so I can extend the parking if I'm out with my kids, which is fantastic for people that actually support that. And then we have this system. Now, most people in this room probably haven't seen this before, but I can guarantee most people in this room can work out what's happening. So at the top here, we define our system, the ticket machine. The ticket machine raises a command. A command is a type of message in our event architectures. A command can be rejected or accepted. Please create me a ticket. No, we do not have any spaces. That's a rejection, that's fine. Commands can be over HTTP as an example here. That could be a synchronous request. If it succeeds, the service can then admit, publish out to say that the ticket has been created. Consumers may or may not be interested, but this service has done its job. Equally, we can also update the car park spaces. We can emit this information to the system. We wrap this in a domain. This is the car park domain. We're dealing with spaces and car parks and all sorts of things. Next, we have parking sessions. We have the customer and extending, please extend this session, and we can raise events off this. So we have these different boundaries, bounded context, different messages, communicating between these boundaries. This event storming is a fantastic way if you're just starting out with your EDA or you want to picture your system. I highly recommend checking that out, and there's resources at the end to help you do that. What I'm trying to say here is that think about behavior first. Thinking, just put some energy into it when you build your event-driven architectures. Rather than diving in and start implementing it, you can save so much time just thinking and doing some upfront design, especially around the behavior. The next thing here is one that seems to trip people up all the time. People don't often think about it. It's about event evolutionary strategies. How do you evolve your events? Now, it's an interesting thing about EDA and APIs and events and APIs, open API specs and all sorts of things. We spent the last 20 years nurturing and loving our APIs. You try and go into a company and implement a new API, I can guarantee they've got 101 different governance strategies to do that. And events, on the other hand, not. So many people come up and they think, how do we evolve our events? How are we going to change this? Who are the consumers? How are we going to break things? And events are an interesting thing. If we take a step back for a minute, why do we even care about events? I don't have an event-driven system. I guarantee you've got events in your system. I guarantee your business probably care about KPIs and events. So I like to think of events tell a story. Okay, so think about this. I woke up today in this hotel. Actually, what did I have for breakfast? How did I get here? What time's the talk? What's the rating on the thing? All these things happening. What did you all eat for dinner? All this kind of stuff. These are events that are emitting. Think about your system. Who's checking out? Who installed the CLI package? Who's dropped off on your system? Who's just paid? All these kind of things are events that your business may be interested in. And then equally, on the other side, we have tables and state of information. So if you query me, which sounds as weird, but if you'd query me, you would see that I'm on the stage right now doing this talk. And modern applications tend to have both, events and state. But with events, it's like, how do we version them? Okay, how do we evolve our events? Now, most businesses, you hope, don't kind of stay in place. We evolve, and our messages, our schemas evolve over time. So we start with version 1, and then we go to version 1, 2, and 2. We follow Semver versioning because we're told that's the best thing to do. Awesome, great, fantastic. Now, at this scale, this is pretty easy. Okay, so now remember, we are event-driven and we have more and more events in our system, and we scale this out. We have versions 1 and 0, 1 and 2 and 5 and 5.1. And it's kind of like, how do we evolve these events without breaking downstream consumers? And without even thinking about this, and as I said, most people trip up here, but thinking about your evolutionary strategies, you'll come to a point when you're building your event architectures, you're just going to start breaking things. Now, what options do you have here? Well, there's not one option that rules them all, unfortunately, but we have options. So number one here is, are we going to be backwards compatible? Is this what we decide as a team, as an organization, for our schemas to be backwards compatible? Okay, are we going to not introduce breaking changes? Are new fields going to be optional in our schemas? Again, this is another thing we can look at. Equally, parallel versions is a good way of doing things, or can be a good way. So version 1 and version 2. Who's consuming the event? We don't know. Okay? So we're going to publish version 2 and version 1 and deprecate version 1 over time. This could work for you. When you talk about event strategies, event schemas, everyone always comes up with this. John Postal's law, and there's some value here for sure. He says, be conservative in what you do and liberal in what you accept from others. Okay? Now this is great when we apply this to event-driven architectures and messages. Be liberal in what we do, we mean keep simple. Right? Why do I need to send the orders and the users? Let's start simple. Be conservative in what we do and be conservative in what we send downstream. Start simple. Now, there are caveats to that. Caveat number one being if your channel, EventBridge as an example, or SQS, whatever, or Kafka, has filtering capabilities, as an example, we can't do much filtering on this. We don't know the user, we don't know the order. So, trade-offs to consider. Equally, as a consumer, is being liberal in what you accept. This event comes in as a consumer. I'm not interested in address, I'm not interested in payments, I'm interested in orders. Orders is the only thing I am going to validate. Again, being liberal, this allows us to be more flexible. Why do I need to validate that whole schema when this is the only thing my service cares about? So takeaway 2 here really is just thinking about this, thinking about defining a strategy. Thinking about this up front, again, can really just help you and save time. The amount of people when I was at AWS, customers I spoke to about EventBridge and all sorts of things, get to the point where they find it hard to evolve this stuff. It's because we've not done enough thinking or planning about that. So I really recommend just thinking about what's the right solution for you. And then equally, the third one here is actually one of my favorites, is actually complexity comes in the way we consume messages. Okay? So this is some stuff out of domain-driven design, but I think this can really help us. So an example would be I am the order service and I share with you the order has been placed. You are all consumers. You may be interested or you may not. When you take this service, you are a conformist. You are conforming. Okay? You are taking my model, my order, what I think is right in my context, and you can apply it in your consumer. Now, this might be okay. You might think, yeah, we understand orders, we understand what this is. This equally can lead to this complexity nightmare. One example being, here is an order that has been placed, and then downstream in a payment service, we start to consume that order model. The order model all of a sudden is everywhere in our code. The properties are in our code. And guess what? When we change that order model, we're going to break downstream consumers because we're tightly coupled in contract. Again, going back, we draw the boxes, we think we're decoupled, but all we've done here is really couple ourselves. So what can we do there? What ways and things can we do there? We can start introducing anti-corruption layers might be a good option. To be able to take that message and transform it into something we understand. So we take that order place, thank you very much, but I am going to protect this domain. You can't talk to this. I'm going to model you into something that we understand, our team understands. We're going to control it at this boundary. Again, this may be an option for you. It may be too much. You may not care. The other one here is open host service. So we push back onto the consumer, the producer, and we say to them, we agreed a contract up front, and that's what you have to do. That order object, that order model, we agreed is an order for the business. And that's what you agree. So you map it, and then you send it. Open host service pushes back. So these are called bounded context mappings in domain-driven design. There's like 14 of them. I recommend diving deeper into that. But the question is, which one do I use? Well, it depends on how much communication you want. Conformist requires high communication. I've just changed the schema. You need to be aware. We may have a meeting about it. You may be the team sat next to me, or remote, or whatever it is. We got this coupling through distance. We're very tight, we're very tight team or organization. That might work for you. Down here is open host service requires less communication up front because we can push back. We push back on that producer, have that initial meeting, and we're done. So it really depends on what strategy you want to use. Depends on that level of communication that you have and that you want. Equally, it's about controlling complexity with distance. Understanding this can help. Private events versus public and integration events in event-driven architectures. As you use EventBridge or you use the brokers or Kafka, no one tells you about this stuff. But you start modeling in this particular way. So we have private events. We are the order service here and here. I am going to send you an event. That type TW is in the event, but it doesn't matter because we understand it. Okay, the model is completely different. Integration events, we're integrating with third parties. We've just created an API that other people can buy using messages. Fantastic. These schemas are completely different to the private event schemas. But we're using the same technology, same channels, same boxes, same diagrams, but the context is completely different. So just controlling and understanding that complexity, that distance itself, has an impact. So here, the three things, like three guardrails you can put in place, right? It's just understanding behavior-first thinking. Just consider this. Understanding that event strategy, how are you going to version your events? Think about that. And equally, defining a coupling strategy. When you consume an event off your event bus, do you want to conform? Is that a problem? Is it not? Should we create anti-corruption layers? Should we do something else? So they're the three things you can take away. And there's one thing left in this talk, really, which is about the biggest gotcha of them all. The biggest thing that will get you no matter what you do as EDA. I speak to many, many people fall into this particular trap, and it's actually quite fascinating to see. So going back to this diagram, we've got our boxes, our lines, we've implemented some guardrails, we wash away that big ball of mud, and fantastic, we feel great about ourselves, this is awesome. But again, as I said, there's one thing that will get you and will bite you, and complexity will come for you. And we often see this when we build event-driven architectures. Okay? These practices that we're taught is that producers should not know about consumers. Okay? Interesting. Technically, yes, this is fantastic. This keeps us decoupled. I don't have to talk to this team over there to tell them that an order has been placed. Great, so what's the problems that start to emerge? Well, people come and go in the organization. That tends to happen. The first questions we're asked, let's say we're tasked to build a new system or AI system, whatever it is. The first question that some engineers might ask is, what events do we have? Okay, and most of the time, the answer to that is, well, you can just look in GitHub, right? I can send you that GitHub link. You can kind of see what events we have. Fantastic. Okay, well, what are the payloads of the events? Well, the schemas. Well, I've just sent you the link. Go away. Fantastic. Also, the interesting thing is, who's consuming what? So I produced the order placed. I have no idea who's consuming this, because I'm told that producers don't need to know about consumers. So I've taken it literally. I have no idea who's consuming it, if anyone is. You may have some metrics and observability, if you're lucky. But it's an interesting thing, and it doesn't, what I kind of get at here is that it doesn't, producers should know about consumers, yes, but that doesn't mean we can skip governance. And governance in event architectures is often overlooked. As I mentioned, APIs, been doing it for 15, 20 plus years. Governance is everywhere, open API specs, the whole shebang. But with EDA, we're kind of at this weird point where we're still trying to figure this out. So what options do we have? Well, thankfully, we have some open source solutions. Number one up here is cloud events. So a specification that allows you to standardize messages between channels and systems. Cloud event guy at the back. But yeah, this is fantastic. So the way I think about this, which I love, is I think about event-driven systems in the future as we connect to streams of information between organizations. How are you going to standardize these schemas? Well, cloud events, again, can help you here. Async API. Has anyone heard of async API? Cool, no one, actually. Awesome. So async API is a specification. A friend of mine, Fran Mendes, he worked at New Relic and found a problem years ago that they just didn't know who's consuming what, who's doing what, and all this stuff. Forked Open API, got funding for the project, and now it's under the Linux Foundation. What async API allows you to do is document your services, document your channels, document your messages, using schemas, using Avro schemas, using different bindings. Okay, interesting, because when we have specifications, we can start building tools. Okay, so here is a specification example on the left. We have the operations that the user signed up, and we have the different channels. This could be a Kafka channel as an example. How can I connect to that? Well, the detail's in there. So when we start having users in the future, it's like, well, if our services had these files, it could help. Here on the right, because we have a standard specification, we can start rendering this out in HTML. We start hosting this. Fantastic. And this leads on to something where an open source project I'm building at the moment to help with all of this, because I'm super passionate about this. Has anyone heard of Event Catalog? Just out of curiosity. Cool, a few people. It's around observability. It's like helping people. This is free to use, MIT license. But it's like, how do you solve some of these problems? And that's exactly what Event Catalog does. It allows you to document your event-driven architectures using Markdown. It allows you to visualize things down here using components. It allows us to search things. We have visualizers here. We can actually visualize services, messages, commands, and queries. Okay, these questions that come up that I saw kept coming up. It's like Event Catalog aims to help with this. Event Catalog here also has different integrations. Kafka, EventBridge, OpenAPI, Async API. Okay, SDKs if you want to automate some of your catalogs. So just remember what I said about that is like them problems. Who's consuming what? Who's producing what? Where are the documentation? This is exactly the vision for the project. And if you're interested in joining along, again, this is free open source. I do this on the side at the moment. But we have almost 800 Discord members, 50 contributors, and about almost 17,000 catalogs created so far. So if you're interested, come along to the Discord and hang out with us and see what you think. But finally here is just managing that complexity, okay, with documenting, and governance, again, can really help you. This is something that's, again, often overlooked. I'm speaking to so many people at the moment, so many enterprise customers. It normally happens at scale later on as you build EDA, but governance and these things will come, and that complexity will come. But thinking about it today, walking away from this session, just placing that seed, again, can just really help you consider some of this stuff. So with that, I just want to kind of summarize this talk. We spoke about designing for evolutionary architectures, the static architectures that you may have resonated with, you may have not. I've definitely seen them in the past. I've definitely seen benefits of evolutionary architectures and event-driven architectures. In fact, that agility and that passion actually got me diving into this for like the past 8 years. Just consider setting some guardrails. Right, just think about that. Think about what can I do to help this system grow? Because I can guarantee complexity, and if it doesn't, please call me up on that. But complexity will come at some point. It's normally around business domains and people and all sorts of weird and wonderful things. Again, in that detail of them boxes. Document your event architectures. You know, I have people like doing that at the moment that just really helps them out. And again, what I said at the start is that potential with event architectures is there. I think it's fantastic. I love this event. I love event-driven architectures. And I think if you manage that complexity, put guardrails in place, think about it, you can actually get more potential out of your system. You know, when you have these problems in the future, you may turn around and say, EDA wasn't for us. But in fact, maybe it's more of we didn't manage that complexity. Maybe EDA can work for us. Here are some resources for you. Here's a free kind of book that I built ages ago called EDA Visuals. You can download this for free. It's like 60 visuals of event-driven architectures I've been diving into, so feel free to grab that. And then all the slides, extra resources, videos, content, everything I mentioned in this talk is on GitHub, and you can find that here. And I just want to say thanks very much. If you want to talk, feel free after or catch me out there, and I appreciate your time. Thanks a lot.